Assalamualaikum and hi to everyone. So in this video, we want to present about our project. And in this project, we make a game and the game calls Rockmaster. This is our members. We have Muhammad Hazad bin Murad, Hafiz Asfar bin Muhammad Masri, Muhammad Daniel Ashraf bin Muhammad Hamzani, Yasmin Ayuni binti Sari, and Nur Alia Sabrina binti Sarbaini. So this is our introduction. In today's fast-paced digital environment, businesses need innovative ways to foster strategic thinking and decision making. At USTU Sdn Berhad, we've developed a strategic management decision game to train employees in handling real-world challenges in the food delivery industry. By simulating tasks like route optimization, resource allocation, and customer satisfaction, the game fosters critical thinking, adaptability, and problem solving. This innovative approach equips our team with the practical skills to excel in a competitive environment while making learning engaging and effective. So next, this is our objective. Basically, we have three objectives. The first one is to encourage employees to develop strategic decision-making skills in a competitive and dynamic environment. The second one is to simulate a real-world challenges in the food delivery industry for improving problem-solving abilities. The last one is to help employees build critical thinking and adaptability for handling unforeseen challenges in day-to-day operations.
Okay, so the data structure that we implemented in this project is graph. Basically, graph is a collection of nodes which are called vertices and line segments called arcs and edges that connect pairs of nodes. Since the goal of our Roadmaster game is to find the shortest path from the source to all other vertices, we implemented Dijkstra algorithm in this project. So here is shown the weighted graph. Okay, based on this figure, vertex R indicates restaurant, vertex G for gas station, and vertices A, B, and C indicates customer A, B, and C respectively. Okay, so all of the edges here, you can see it is bidirectional, in which the delivery route and return route have similar distance, which is the weight. Okay, so this is the table after we applying Dijkstra algorithm. Okay, so let me first explain the Dijkstra algorithm in two steps, which is first, we pick a vertex, call it W, that is not in S, and for which the distance from R to W is a minimum, we add it to S. And the second step is for every vertex still not in S, we see whether the distance from vertex R to that vertex can be shortened by going through W. If so, we update the corresponding element of this. Okay, so here let me explain each of it. Briefly explain. Okay, so for R, W is 9, so which means that R is directly to G, A, and to B, and to C. So the shortest path from R to G is 4, to A is 5, to B is 10, and to C is 8. Okay, and then we pick the second row, we pick G as the W, but there is still no change in the value. Okay, and the third one, we pick A for the W, and here there is slightly difference, which we R to B, when going through A, it is shorter compared to previously R to B directly. So when going through A, R to A and to B, the value is 8, but previously R to B is 10, so we update the value of 8. And so on, the C as the W, B as the W, the value is still the same. So here is the summary of the table. Next is the output for the shortest path. Okay, after we do the table, we can see each column the minimum value of the path. So for vertex G, the shortest path is 4 with the predecessor 1. For vertex A, the shortest path is 5 with the predecessor also 1. And vertex B, the shortest path is 8 with the predecessor 2. Like we must visit two vertex. And lastly, for C, the shortest path is 8 with the predecessor is 1.
In this slide, I'll be explaining the pseudocode behind the root master game, which simulates the delivery process. So this game helps the workers practice decision making by navigating delivery routes, completing quests, and also managing resources such as the car health and fuel. So in the pseudocode, I only implement 4 out of 6 classes. So the other 2 classes I didn't implement in the pseudocode. These 2 classes are known as the H class and also test program class. I will tell you the reasons after I explain these 4 classes that you see on the slide. Okay, first class is the graph class. It is responsible for managing the locations, also the routes in the game. It stores the locations as vertices and also the roads as the edges. It uses the Dijkstra algorithm to calculate the shortest path between the locations. Next is the locations class. It represents each specific locations on the map, such as the restaurant, the customer, and also the gas station. So each location has a name and coordinates which help in placing them on the map. Next is the quest class. Quests are randomly generated where each quest has a target location and also a reward based on the successful completion. So it also handles the customer complaint handling. Lastly is the delivery game class. It is an integration of all classes. It coordinates the interaction between these components to ensure the smooth gameplay. So I will tell you the reasons why H class and also test program class are needed in pseudocode because first the H class, the routes and also their distances are already managed within the graph class. Meanwhile, for the test program class isn't needed explicitly because in the play game method that you will see in the delivery game class already handles the game loop and also the logic to run the application. So that is why the test program are needed for the pseudocode. Okay, so I will dive into the pseudocode writing. So I will explain each classes and I will be focusing on each method in each class. Okay, so for the graph class, I will be focusing on the Dijkstra method here. So this Dijkstra method is the core of the road optimization. Next is the distances and also the predecessors here. So these two are used to store the shortest distance and also the path. Next is the PQ, which is known also as the priority queue. So this priority queue is to ensure the locations are visited in the order of shortest non-distance. Next is the reverse path here. So the reverse path here is when the destination is reached, we backtrack using the predecessors to form the shortest path. Next, we're going to look into the location class. So for the location class, I focus on the setup locations method and also the display map method. So for the setup location method here, this is where the predefined locations like the restaurant and the customer A and also etc. are set with their coordinates. And lastly is the display map method here. This prints out the map for the player to visualize where they are and where they need to go. Next is the quest class. So for this quest class, I'll be focusing on the target location and also the reward points. So these two variables define the locations the player must deliver to and also the points they will earn. So and then also the constructor method here, it initializes the quest with a target locations and also a reward points. And lastly is the delivery game class. For this delivery game class, I focus on the setup game method and also the play game method. So for the setup game method, as you can see, this method sets up the location, the roads, and also initializes the game with the starting conditions. And lastly is the play game method. So this method drives the gameplay where the player is assigned quests and the game track resources like car health and also fuel. Also, the Dijkstra method also uses because it is used to calculate the shortest path for each quest. I forgot to mention also that for this delivery game class, it is a backbone of the game where it integrates all the components of the graph locations and also the quests. So this is all for the pseudocode writing.
Next, I will talk about the programming code in Java language. For these presentations, I will only talk about the Dijkstra algorithms. So now let's look at the Java code. The algorithm starts by initializing a priority queue and a distance map. The priority queue helps us process nodes with the smallest distance first. Then we enter a while loop where the algorithm continuously checks the shortest possible path to each connected node. The distance is updated dynamically as we explore the new path. And if the destination node is reached, the algorithm backtracks to reconstruct the shortest route taken. This code ensures the efficiency by using a min heap, or we call priority queue, which allow us to always process the shortest path first and reducing the unnecessary computations. So for the conclusions, this implementation of jigsaw algorithms is essential to find the optimal route in these applications. Let's move on to the program execution. So this program simulates a delivery-based games where the player must navigate through a city to complete quests efficiently and not choosing the longest path. So for the determining the best routes during the gameplay, the Dijkstra algorithms must play a good role to help the player. So the game starts by initializing the locations like the restaurants, the customers A and customer B and also customer C. And there is also a gas stations to refuel or repair this car. Next, the game begins and the player takes on the road. The player must decide which roads they should take while considering the key factors like the shortest path, the car fuel, the car health, and also the way to complete the quest. And moreover, there are also challenges like navigating the city for the first times, and there will also result in points, handling customer complaints, for late orders, and also find shortcuts to improve efficiency. So these challenges may come with the penalties and also extra points. So at the end of the games, the player is scored based on the delivery performance and how well they manage their resources. If they successfully optimize their routes, they may earn more points. So, additionally, resources management plays a crucial role. For example, like if the player doesn't refuel on time or the car have below the should be, the game may over. To conclude, this program integrates with jigsaw algorithms in a game environment to help the player make strategic decisions on the best roads.
For now, we will go to the output validation. So the first output that will appear is like this. There are 5 nodes, which is restaurant, customer B, customer C, gas station, and customer A. All these nodes will be represented by using grid representation. Then the player will see, welcome to the road master game. It also displays 2 rules for the player to take note. And to start the game, the player just need press the enter button at their keyboard and the game will start immediately. The game starts with the current location given. For this case, the location is the restaurant. And you also can see the car head and fuel. Then there is a quest for player to complete it to get points. For this case, the player managed to get the shortest path to complete the quest, where it need to deliver from restaurant to customer B. To do it, the player must enter the next location of restaurant, which is customer A, then must go to the customer B to deliver it. As you can see, the shortest path is from restaurant to customer A and to customer B, where the total path is only 8 compared to another path, as you can see in the graph beside here, which is 10, which is more longer. After that, the player will earn 20 points plus with the extra 10 points. What if the player choose the longer path? Based on the graph, the longer path is from restaurant to customer B is 10. And if the player enter it, the player just get 20 points only, because of the longest path chosen. Moreover, to give an intense and amazing experience to the player, we actually add some feature like hidden challenge and bonus. So the first hidden challenge is the customer will complain and the player need to respond immediately in 10 seconds. If not, it will deduct by 10. And if the car will have an issue such as flat tires, it will deduct 10 of the car head. And the third hidden challenge is navigate error where it will deduct 10 of the final point. Not only that, we also add bonus point of 10 where it will be given for the bonus event. All these hidden challenge and bonus, it will appear randomly while playing the game. Did you remember I have told you about the car hack and fuel up the car? So how the player be able to do it? First, the player must find the path go to the gas station. At the gas station is the place where the player can refuel up or repair the car so that the game will always continue. What if the player giving up to find the path or just start dying without reach to the destination? Is that down here? The output you miss the quest objective will appear and the player will not earn any point. In addition, what if the player entered invalid input? If the player entered invalid location, the error message "Invalid location, please try again" will appear, and the player is required to choose the correct location again and again. If the player enters the wrong location, it's like down here, it will display no direct route to the entered location and required player to try again. Lastly, how the game ends. The game ends with three different ways. When the game ends, the screen will display the final score here and completed quest that has been done by the player. First, if the car breakdown, which is the car health is under 40, the game will end automatically. Second, if the car run out of the fuel, which means the fuel is under 0, and the game will also automatically. And last one, if the player is giving up and don't want to play the game anymore, the player can enter no to continue the game, and the game will end. And that's all about the output validation. Thank you for your listening, and I will pass to the next presenter.
Next, this is our conclusion about this presentation. The Roadmaster game is a cutting-edge training tool that equips US2 Sdn Bhd employees with the critical skills like strategic decision-making, resource management, and route optimization. By simulating a real-world challenges with a dynamic event and rewarding a gameplay, it fosters adaptability, innovation, and teamwork. So this aligns with the US2's commitment to excellence, ensuring employees are prepared to thrive in the fast-paced food delivery industry while delivering exceptional customer satisfaction. So I think that's all from us. Thank you so much.